895 feet. That's the elevation where Lake Mead hits dead pool, where water stops flowing through Hoover Dam. 25 million people depend on what is behind that concrete. The lake has already plunged 140 feet toward that threshold. At 895 feet above sea level, Lake Mead reaches what engineers call dead pool. This is the line in the sand. Once the water drops to that point, it sits too low to flow through Hoover Dam's turbines or outlet works. There is no more water moving downstream and no more electricity generated. The entire lower Colorado River system grinds to a halt. For cities and farms across the Southwest, this is not just a technical milestone. About 25 million people depend on the water stored behind Hoover Dam. Their taps, fields, and lights are all tied to a reservoir that has been shrinking year after year. Every foot lost is not just a number. It is a step closer to the point where water cannot be delivered and power cannot be produced. The dead pool threshold is not a distant hypothetical. It is a hard engineering limit written into the Bureau of Reclamation's manuals, and it defines the moment when the system stops working as designed. In 2022, the daily gauge at Lake Mead recorded a reading of just about 1,040 feet above sea level, the lowest point since the reservoir first filled in the 1930s. This number alone doesn't capture the shock, but the evidence is written across the landscape. Along the canyon walls, a stark white band, the so-called bathtub ring, marks where water once touched rock. That ring now towers above the current shoreline, stretching up more than 140 feet in places. This is not a subtle change. From the historic full pool elevation of 1,229 feet, Lake Mead has lost the equivalent of a 14-story building in water height. The missing water adds up to nearly half the reservoir's design storage, a deficit visible from space in satellite time-lapse sequences that show the lake's blue shrinking year after year. For engineers and everyone who depends on this system, the 1,040-foot reading was more than a number. It was a warning that the reservoir's margin for error is running out. The roots of the crisis trace back to a single number, 15 million acre-feet. In 1922, state negotiators sat down to divide the Colorado River, using a brief window of river flow records that looked unusually generous. They wrote into law that the river could reliably deliver 15 million acre-feet of water each year, and they split that amount evenly, 7.5 million acre-feet for the upper basin, 7.5 million acre-feet for the lower basin. But the river itself had other plans. Modern studies, drawing on more than a century of data, reveal the actual long-term average is closer to 13 million acre-feet. That means the compact locked-in promises that outpace what the river can deliver by 2 million acre-feet every year. The law treats these allocations as untouchable rights, leaving the system chronically overdrawn even before drought or climate change come into play. What began as a paperwork solution became a structural deficit, one that is baked into every contract, every water delivery, and every negotiation that follows. Tree ring records and ancient lake sediments reveal a harsh truth. The Colorado River Basin is now in the grip of one of the most intense droughts in over 1,000 years. Modern climate data backs this up. Since 2019, the Palmer Drought Severity Index has hovered between -6 and -8, well into the extreme range. But it's not just the lack of rain or snow. Warmer temperatures have pushed more water straight into the air through evaporation and thirsty plants, leaving less to flow into Lake Mead. Even during winters with heavy snow in the Rockies, the runoff often vanishes before it ever reaches the reservoir. Dry soils soak up the first melt, and hotter air means a greater share never makes it downstream. Hydrologists estimate that even a 15% boost in snowpack would barely raise the lake by 6 feet, a drop in the bucket compared to what's missing. As climate scientist Miguel Gomez puts it, the Southwest megadrought is a compound event. Less snow, more evaporation, and a system now outside its natural limits. The river is no longer just overpromised on paper, it's shrinking in real time. Hydropower at Hoover Dam is all about pressure. Engineers call that hydraulic head. When Lake Mead was full, the dam's turbines spun with the force of a 726-foot column of water, delivering up to 2,080 megawatts of electricity. But as the water drops, so does the head. Each 10-foot fall slices off about 2 to 3% of the dam's power. Since 2000, Hoover's annual generation has dropped from over 15 terawatt hours to barely 10.5 terawatt hours. By 2022, with the lake around 1,040 feet, the plant was running at only about 3/4 of its design output. As one Bureau engineer put it, every foot lost is megawatts lost. The grid that lights up cities from Las Vegas to Los Angeles depends on this pressure. When the head shrinks, the Southwest power supply grows more fragile. Las Vegas refused to wait for a miracle. As Lake Mead's level kept dropping, city engineers authorized a project that would have been unthinkable decades earlier: a third intake tunnel bored deep into the bedrock beneath the reservoir. This tunnel, nearly 1.9 miles long, reaches down to about 970 feet above sea level, far below the older intakes. The idea was simple: keep water flowing to the city even if the lake fell to record lows. With this new third straw, Las Vegas could draw water when other systems would already be dry. Project manager Kerry Thompson summed up the urgency, saying they needed a lifeline that could reach the last drops, but every foot deeper exposes a hard truth. Engineering can buy time, but it can't create water. The third straw keeps taps running in Las Vegas, but it also spotlights the limits of patchwork solutions. As the tunnel came online, questions grew louder about who gets to draw from a shrinking supply and for how long. In 2026, the Colorado River Agreement expires. Decisions loom. The dam stands strong, but water is vanishing. This isn't an engineering failure, it's a warning that the Southwest lifeline can't be taken for granted. What would you do if the river runs dry?